Hello everyone, this is subject ECE-5831 Pattern Recognition and Neural Networks. These are my teammates Rakshita and Radhika and myself Ananta. So our project is emotion detection in text using pattern recognition and neural networks. So we have built an emotion-aware chatbot that detects the emotion from user text and responds empathetically. Here we'll be walking through the rest of the presentation. So we have the agenda. So there is the problem and motivation, the prior work, data set and pre-processing, model architecture, chatbot features like emoji responses and memory recall, results and evaluation. Then we have the limitations, ethics, and future work. Coming to project overview and key features. So our project is an emotion-aware chatbot which is built using a Gradio chatbot interface for real-time interaction. Our system takes a user message and then predicts one of the four emotions. They are happy, sad, angry, or neutral. Based on that emotion, it generates a reply using empathetic templates with the emojis so that the tone is very clear. We have also added session memory, which stores the earlier user messages and supports recall questions like, "Do you remember what I said?" Finally, we show a probability plot so that the users can be able to see the model confidence and also interpret the predictions. Text emotions check in. How do you feel today? I'm feeling great. Thanks. So, coming to problem and motivation. So, the emotion matters a lot in conversations. This chatbot can detect user emotion and can respond differently to an angry user versus a sad or a neutral user, which improves the user experience. This is very useful for customer support, review understanding, and human AI interaction. Our goal was a lightweight model that works in real time while still capturing the context. So here we have the prior work. So early text emotion recognition relied on classical machine learning like naive Bayes or SVM with handcrafted features which often missed the contextual meaning. Deep learning approaches like LSTMs and transformer based models improved the performance by modeling the sequence patterns and word dependencies. In real chatbot deployments, emotion detection is often paired with rule based responses to keep replies consistent, controllable, and fast. Over to you, Radhika.
Hello everyone, I'm Radhika. I'm going to present a data set and pre-processing. We used a labeled emotion dataset and mapped the original labels into four final classes: happy, sad, angry, and neutral. Our pre-processing includes cleaning, normalization, tokenization, and padding into a fixed sequence length so text can be fed into the neural network. We also addressed class imbalance using balancing strategies to avoid bias toward the most frequent emotion. Next, model architecture. Our main model is a bidirectional LSTM. We use an embedding layer to learn word representations, then a bi-LSTM to capture context from both directions. Dropout helps from prevent overfitting, and a final dense softmax layer outputs emotion probabilities. We also trained a baseline model using TF-IDF plus logistic regression for comparison and as a sanity check. Next, end-to-end system pipeline. The complete pipeline is user text to pre-processing. Then after pre-processing, model predicts user text with the probabilities, emotion selection with a confidence fallback, and response get back from generation using emotion templates with the emojis. Then finally display results in the Gradio interface with a probability plot. This makes the output more transparent and more user friendly. Next, conversational memory with using TF-IDF recall. One key enhancement is conversational memory. The chatbot stores the user's previous messages in the current session. If the user asks a recall style question, we compute similarity between the question and the past messages using TF-IDF and cosine similarity with retrieve the most relevant earlier statement. This makes the chatbot feel more coherent across turns. On this slide, project files and how to run. I'm summarizing the key project files and the exact steps to reproduce our results. The main training entry point is train.py, which loads the dataset, runs pre-processing from data pre-processing .py, trains the BiLSTM defined in model.py, and also trains a baseline model in baseline.py for comparison. After training, it saves artifacts in the models, for example, the folder including the best saved model, tokenizer, and evaluation plots like the training curves and the confusion matrix. To run it, I first install dependencies using requirements.txt, then place the dataset under data or under the folder emotions dataset for NLP. Under that, train.txt, val.txt, and test.txt. Next, I executed Python train.py under the folder data, under the folder emotions dataset for NLP, like this, to train and generate the saved outputs. Finally, to launch the interactive chatbot, I run python app.py, which loads the trained model and the tokenizer that uses response templates from responses.py and displays the Gradio UI user interface. So we can test emotion detection, emoji based replies, memory recall, and the probability plot in real time.
Hello everyone, I am Rakshita and I will take over from here. So, here are the training and validation accuracy and loss curves. We see the model learns quickly and stabilizes, and the validation trends remain close to training, which indicates our regularization choices like dropout helped or reduce overfitting. This supports the model generalization beyond the training set. Next is results and confusion matrix. So here, this slide shows our test performance using matrices like accuracy and macro F1 along with the confusion matrix. Most predictions are correct and the common mistakes happen between emotions with similar wording. For example, mild frustration vs neutral. This is expected because short text can be ambiguous and emotion levels can overlap. Chatbot UI and interactions. So here, so on this slide, we are showing the chatbot interface built with Gradio. The left side displays the conversation history and each user message is passed through our pre-processing and the trained model to predict an emotion. Based on that prediction, the system returns an empathetic reply using text templates plus emojis, which makes the tone very clear for the user. So here on the screen, you can see that we have fed that I am excited to go on a vacation. It predicted as happy as it was an happy text, and also it shows the confidence level. So going further, like we fed that I am fine to get everything. So it was a neutral sentence. So it detected as neutral, same as continued for I am worrying and not feeling well. So that is detected as sad. In addition to the responses, we also display a probability chart of the four emotions. This is important because it shows how confident the model is. So the user can see whether the prediction was strong or uncertain. Finally, the screenshots also demonstrate the memory feature. The chatbot stores earlier user messages during the session, and when the user asks something like, "Do you remember?" it retrieves the most relevant prior message using a lightweight similarity method. Overall, the slide shows how we turned emotion classification into a complete interactive system, not just a standalone model. So here we fed that my favorite color is purple. So it shows that great. That's great. Tell me more. Then we said, do you remember what was my favorite color? Then it said my favorite color was purple. Now let's preview the quick chatbot demo. So here we'll feed some sentences and let's see how it predicts in life. So it's I am excited to go for a vacation and it predicted as happy with the emotion probabilities. So let's see what is the next sentence. It is I am frustrated when I am doing wrong. So it was an angry sentence as I was frustrated. It also shows the confidence level. So I'm worrying about my health. It was a kind of a sad sentence. So it replied in with text plus emoji. And then we said, my name is Ratika, which is a neutral sentence. Let's see if it remembers my name or not. So I remember you said, my name is Ratika. Next is challenges and mitigations. Our main challenges were ambiguous sentences, emotion overlap, and class imbalance. We mitigated them through improved preprocessing, class balancing, dropout, and confidence based fallback. The memory recall feature also helps the system handle multi turn interactions more naturally. Limitation, ethics, future work, and wrap. So, we currently predict only 4 emotions, and sarcasm remains difficult. Ethically, emotion detection should be used carefully. Avoid storing sensitive user text and avoid giving medical advices. Future work includes expanding to more emotions, trying a transformer model like Distilbert, improving long term memory, and stronger safety handling. That concludes our project. So, here are some references whose background methodology we followed. Thank you, and we are happy to take any questions.